Hello, in this video I'm going to introduce you to planes. So to do this we're going to start off by looking at 3D space and how we can plot points in 3D and what it means. And then we're going to introduce the idea of a plane, so what a plane is. Really it's just like you can imagine a sheet of paper extending out infinitely in all directions. And then we're going to see how we can describe these with a simple equation. Okay, so if this video is useful, please do like and subscribe. We'll already be familiar with, which is 2D space. So we're familiar with the X and Y axis like so. Now if I want to plot a point in 2D space, well, I write my X coordinate first and then my Y coordinate. So I'm going to say plot the point 2, 8. So that means going across 2 in the X direction and up 8 in the Y. And if I plot that point, it's going to look something like this. So let's now introduce a third axis, okay, and I'm going to call this the Z axis, and this will transform this into 3D space, because now I can go forwards and back, left and right, and also up and down. So let's say we want to plot a point in this space. Well, let's say we want to plot the point 0, 0, 2. Well, that means that I'm remaining fixed in my x-axis. I'm not moving forwards or backwards, whatever you want to say, left or right. Then for my second, my y-coordinate, I'm still at 0. I haven't moved in this direction. But for my z part, it's 2, which means I'm going up 2 in the z-axis. So if I plot that point, it's going to look something like this. Now, let's say we want to plot a point that isn't on one of the axes. Let's say we want to plot a point just somewhere in space. Let's say the point 3, negative 1, 3. Well, this means I'm going across 3 in the x direction. I'm going back 1 in the y, and then I'm going up 3 in the z. And if I plot that point, you can see it's going to look something like this. So this is what our 3D space is and how our coordinates are going to work in 3D space. Now let's introduce this idea of planes, which you can think of almost as like a sheet of paper that's going to extend infinitely in all directions. Okay, and we're going to use this with our matrices to do reflections, because in 3D space, rather than reflecting in a line, we're going to reflect in a whole plane. You can imagine like a mirror that we would see. So the first plane we're going to look at, I'm just going to remove these points, is going to be what we call the XY plane. Okay, and that's going to be the one that you can kind of see, which is graphed out here. So the XY plane is, if you imagine I'm just looking at my X and Y axis like this, if I've got a sheet of paper that covers all of it, and I'm going to put it on in color in a minute so it'll be a bit clearer to see. But when that happens, you'll hopefully realize that, well, all of my Z coordinates must be 0, and then I can move around X and Y as however I like, but Z will always be 0. And so the XY plane can be described by the equation Z equals 0. And if I plot that, you can see all of my Z coordinates are 0, and I can move around the XY sort of axes like so. Okay, so that's the first one. Let's now look at the YZ plane. So if I rotate it around like so, this could be my YZ plane. Okay, so it's where I can move around freely for Y and Z, but I have fixed X equal to 0. Okay, so if I plot the equation X equals 0, it's going to look like this. Okay, and this is my YZ plane. Hopefully you can see why that is. And my final one is going to be my XZ plane. So that's this one here. Okay, so it's all of this space that we can see there. And this is going to happen when I have my Y equal to 0. So if I plot Y equal to 0, you can see I get my XZ plane. So hopefully this video was useful. If it was, please do like and subscribe, and go over to my channel where I have loads of other maths tutorials. Thanks for watching.